Hey guys, today we're going to have a look at the angles in quadrilaterals, and the rule for that is just that the interior angle sum of quadrilaterals is 360 degrees. Now, that's very similar to the interior angle sum of a triangle, which is 180 degrees, because quadrilaterals, if I split this down the diagonal here, quadrilaterals can be made up of two triangles. So that's why it's double the number of degrees. However, just having this rule here is not going to be enough to be able to help me find all of the angles inside a quadrilateral. It would really only help if I already knew 3 angles and I was just looking for the 4th one. So we're going to need to remember the names of quadrilaterals as well as their properties and the other angle rules that we've been studying. So let's get started. Over here I've got a rectangle, and I know you're probably tempted to call this a square because it may look sort of like a square, but unless we've got the markings on it to say that these sides are all equal, we can't make that assumption. However, a square is a special type of rectangle. It's got the same angle properties, it's just that rectangles don't have all sides equal. So we still use the same rules. The next one here we've got is a non-isosceles trapezium. It's a trapezium because it's got a pair of parallel sides that are different lengths. This one's definitely shorter than this one, but it's not an isosceles trapezium because it's missing the symmetry that an isosceles trapezium would have, because this length here is not equal to that length there. Okay? Next we've got this shape here, and hopefully all of these markings make it really obvious what shape this is. I've got 2 pairs of parallel sides, which makes this a parallelogram. And that means that we're going to use all of our parallel line rules on this one, our parallel angles. Right, these next 2 shapes here, I know that some of you want to call these diamonds, but please don't. They are not diamonds. Diamond is not a mathematical term for any kind of quadrilateral. This one here has got all sides equal, and that's what makes this one a rhombus. It's like a type of parallelogram because although it's not labeled, this side here is parallel to this side here, and this side here is parallel to that side there. So it's kind of cross between a parallelogram and a square because I've got all sides equal, but I've also got the same rules as a parallelogram. Right? This next one down here, again, it's not a diamond and it's very different from the rhombus. I've only got 2 pairs of equal side lengths. They are not all equal to each other, right? This one is a kite. These 2 sides are equal to each other and those 2 sides are equal to each other. There are other rules about a kite that we're going to get into in a minute, and that's going to help us to find our angles. But for now, we need to know the difference between a rhombus and a kite and their names. Lastly, we've got this shape down here, and I want to say it's a parallelogram, but I'm going to wait and first make sure because I know that these sides are parallel to each other, but I want to check if those ones are parallel to each other. And if they are, then that would mean that these angles follow the parallel line rules, right? But for now, I could say that these are 2 different shapes. This one here is a trapezium. I can tell it's a trapezium because it's got a pair of parallel sides which are different lengths. They're definitely not the same length. But this is an isosceles trapezium because the other sides are equal to each other. And this other shape over here, it's a triangle, but more specifically, it's got all sides the same length. All sides are equal, which makes it an equilateral triangle. Okay, so there's my isosceles trapezium, and there's my equilateral triangle. So that should be enough to give us a good start on finding the angles. So we're ready to start up here with this rectangle. And one thing that you should know about rectangles is that all angles are 90 degrees. All angles. In that case, I already know what all the angles are, and it doesn't require much algebraic working. I just want to write my rule up here above, and then I can go ahead and write my answers. So that means that A equals 90, and B equals 90, and C equals 90, and D will also equal 90 because it's a rectangle. Okay, now please don't switch off now. I know that seemed easy, but we are getting some more challenging ones, and you're going to run into some of these on the exercise as well. So you're going to need this. Next one, we've got a non-isosceles trapezium. That means these sides are not equal, but I do have parallel lines. So I'm going to use some parallel line theory here, starting with this here. This angle A and the angle 52, notice what shape that makes. Is that an F, a C, or a Z? I see a C pattern there, which we call interior angles. So I'm going to put the rule, interior angles. And just to be clear, it's a C pattern. And that means that A and 52 add to 180. A plus 52 equal 180. Okay. So now that's going to require a little bit of algebra for me to solve. I want to find out what A is, so I need A on its own. I'm going to move the 52 to the other side. A equals 180 minus the 52. Okay. Now that's not finished yet. I need to work out what A is. So A is equal to 180 minus 52. That's going to be 128. Right? I've found A, now let's find B. Once again, looking at angle B here, it does not make a C pattern with the 52 because this line here is not parallel to this line here. However, B does make a C pattern with the 104. It's a backward C, but it is between two parallel lines with one transversal line, so that is another C pattern, an interior angle C pattern. Okay, so I'll go ahead and write that rule, interior angles. And again, to make it clear it's a C pattern, we really need to use the rules, though, the words interior angles. The C is just to help us to recognize it. Okay, and that would mean that 104 plus B equals 180, which means that B on its own is equal to 180 minus the 104, right? So once again, B is equal to 180 minus 104, that's going to be 76. Okay? So I'm showing all my working here, including what my rule is. That's helped me find my answers. Now I could always do a check, and I should really do this check to make sure that A plus 104 plus 52 plus B, all of that added together should make 360 degrees. So go ahead and check with your calculator. I hope that's right so that we can move on. And let's go on to the next one, which is the parallelogram. So parallelogram, by its name, once again, we're going to be using a lot of parallel line rules here. Starting with A. I like to go alphabetical. Usually the questions are set up so that I can solve A, and that'll help me find B, which will help me find C. So I'm going to start with A here. And once again, I see that A, related to the only angle I know, again, if I trapped that A, that angle A, and the angle 61, let me just show you, that's going to make a C pattern. So if I draw angle A, so that's one line that traps angle A, that's the other line that traps angle A. And if I do the same thing for 61, so I'll draw one line down here for 61 and one line over here. Just drawing 61 and angle A, that joins together to make a C pattern. So we can go ahead and write that rule. Interior angles. And that makes a C pattern. Again, I'm just writing the C there to help you. But we need the rules, the words interior angles. That means that A plus 61 is equal to 180, which means A on its own equals 180 minus the 61. So finally, I've got A is equal to 180 minus 61. That's going to be 119. Okay, so I've got A. Now to find B, because again, alphabetically, usually it works out really well. Again, with B, I've got another parallel line rule here. Let me draw B for you. So B is this angle here. I'll draw that line. And I'll draw that line there. And if I join that up with the other angle that I know, so I'll draw this line here for the 61. And I'll draw the line across for the 61, joining it to this line here. You'll see that it also makes a C pattern. There's no such thing as a U pattern. It's a C pattern, but it's lying down on its side. It's taking a rest. Okay, so let's go ahead and write that. These are interior angles again. So that's a C pattern. I've just noticed over here I missed my M. No big deal, you know what I mean. Interior angles, so that's a C pattern. So that means that B and 61 will add to make to 180 as well. So B plus 61 equals 180. And I've written something very similar to this before. I said that A and 61 makes 180. That's because A made a C pattern with 61. B also makes a C pattern with 61. And you'll notice this about parallelograms. That means that A is equal to B. Right? I don't really need to work this out again. I already know that if A plus 61 makes 180, that means A is 119. Same thing as B. So I'm just going to go ahead and jump down to that answer. B is equal to 119. Okay? Now we're just left with C then. There are two different ways that we could do this. We could say that C is also in a C pattern with B, or C is in a C pattern with A. So maybe there's one third way. There's also the fact that this is a quadrilateral. So let's use our new quadrilateral rule. So I'll go over here. Let's put this in a different color just to be colorful and nice. And angle sum of quadrilateral. Now the angle sum of quadrilateral, we know it's supposed to add up to 360. So that means that A plus B plus C plus 61 equals 360. A. I already know what A and B are, so I'll just substitute those in. That's 119 plus 119 plus C plus 61. That should equal 360. My equal signs aren't lined up. I really like to have my balanced equation, so I'll line that up. Okay, 119 plus 119, that's going to be 238, plus the 61 is 299. So 299 plus C equals 360. Oh, I don't know why this isn't going the color I want. There we go. And let's shift that over because again, I like them lined up. That means that C on its own has got to be 360 minus the 299. C equals 360 minus 299, which means C on its own is going to be 61. C equals 61. Now, notice that about our parallelograms. I didn't mention that at the beginning because I did want to practice our rules, but parallelograms have two pairs of parallel sides. They also have two pairs of equal angles. And I'll go ahead and label that in here so that you can see all the working that I've done. You can see my answers, and maybe that'll help you in the future. So this is 61. And this one was 119. Put this in red. And this one down here was also 119. So put that in green. Okay. Right, so we're ready to go on to our rhombus then. Again, every time we're going to write the rules, we're going to show our working. The algebraic working is really what you need to show me that you're able to do now. With a rhombus, it's a special type of parallelogram, so although I haven't labeled my parallel sides, I can use my parallel line rules. But here I didn't give you any of the angles inside the quadrilateral. I just gave you this one angle outside the quadrilateral. But I'm being very careful not to call that an exterior angle because it doesn't make a straight line with angle A, not in either direction, so it's not going to add with A to make 180. It makes a full turn with the angle A, so that's going to add to make 360. So let's start with that as our first rule. That's angles in a full turn. and that's angle A and 200, and they must add up to 360 because angles in a full turn make 360 degrees. So A plus 200 equals 360. That means A on its own is going to be 360 minus the 200, which means A on its own is going to be 160. Okay, so I've got A. Let's see how that's going to help me to find out what C and B are. First of all, remember this is a parallelogram. That means that with A and C, I've got a C pattern. Let me show you my C pattern. So here I've got angle A between this line and this line. And I've got angle C between this line. And if I just draw that last line a little bit longer, you can see my sideways C pattern. Okay, so let's go ahead and write my interior angle rule here. These are interior angles. And that means that they're going to add up to 180. So that means angle A plus C equals 180. A I already know is 160 plus C equals 180. So C on its own, and I want to line up my equal signs. If I'm taking this effort to do this while I'm typing, and you can see it is more work typing, I expect you guys to do it while you're writing. So lining that up, 180 comes first, the 160 comes after that. It was plus, now it's minus, so C is going to be 20. It's all in black. Okay, so I've got C. Let's work out what B is. So this next rule we're using because of rhombus symmetry. So I know that A is equal to B, or putting it the way that I want to solve it, I'm trying to find B, so B equals A. I know A is 160, so B equals 160. Now we could always do a check as well. I could say that this over here has got to be C because they are equal to each other because of that line of symmetry. And then I could do a check that A, B, C, and C add to 360. So if you like, you could do a check that A plus B plus C plus another C. That should add to 360. Not 306, 360. Right, let's go on to the kite now. So this kite, as I said, it's got two pairs of equal sides. It's also got a line of symmetry. So I'm going to start by showing you that. Here's my line of symmetry. Knowing that this side is equal to this side and this side is equal to this side, I've got my line of symmetry here, which is going to help because that means that not only are the sides equal, but angle A is the same as this angle up here. And I haven't given you enough information to find out what B is, nor have I really given you enough information to find out what A is. But if I tell you that there are two A's in this question, I've got another A up here. Because of the symmetry of kites, I can work out what A is, and that'll help me to find what B is. So I'm going to go ahead and write that that's the rule that's helping me to find this. Symmetry of kite. Okay. And that means that I've got two A's in this question. I've got A, and I've got another A, and I've got 40, and I've got 30. And that, because of the rule of angles in a quadrilateral, that should add to 360. So I should add that up here as part of my rule. Angle. Right, so let's go ahead and solve that. This is going to require some algebra. I've got two A's here, so let me simplify that first and say that that is 2A. Plus 40 and 30 is 70 equals 360. Lining that all up nicely. Let's move that equal sign over. I want to get A on its own, which means I should move the 70 to the other side. So here I've got 2A equals 360 minus the 70, which is going to be 290. So A is equal to 290 divided by the 2. On that side it was multiplied by 2, so I've moved my 2 to the other side, and now I'm dividing. Finally, I've got my answer here. A is equal to half of 290 is 145. So I've got A is 145. Let's see how that's going to help me to find B. Now, saying that this down here is 145 doesn't seem to help with the B. However, I know that this is also A, and I know that A and B make a full turn together. So I'll write that as my rule. Angles in a full turn. And that means that B plus A makes 360. I already know what A is, so that's B plus 145 equal 360. Again, I want to line up my equal signs, which means that B on its own is 360 minus the 145. So B must therefore be equal to 215. It makes logical sense that B is such a big number because look at B. B is a reflex angle. Right, let's go on to our last question now, and this is probably our most interesting question because I've got two shapes put together here and I didn't give you any of the angles. So you need to know the angles of these shapes, starting with the triangle. We know the interior angles of a triangle add to 180. Let's write this as our rule, so I'll start this off in a different color. Int angles of triangle. And this is an equilateral. The interior angles of a triangle are 180 degrees, but these angles are all the same. So if I do 180 divided by 3 is going to give me the angle of each of the angles inside this equilateral triangle, and that is 60 degrees each. Okay, so I know that this angle here is 60, and it helps if I label that on my diagram. So I'll put this 60 here. Let's put this in blue so you can see my working goes along with my answer. Okay, so that's 60 degrees, and that's going to help me with A, because looking at this shape here, although that 60 degrees is inside the equilateral triangle, it is outside of my isosceles trapezium. It is an exterior angle because it makes a straight line. It continues just this straight line. It's an exterior angle of this trapezium, and it makes a straight line with angle A. So I'm going to make that my next rule. Let's do this in red. So int plus x equals 180. And we're talking about the interior and exterior angles that are A plus 60 equals 180. So A on its own must be equal to 180 minus 60. That makes A 120. Okay, I've got A. Let's see if we can find B, C, and D. B. Let's do this in a different color so I can show my working here. B is going to be inside a parallel line rule with angle A. I'm always going to use the angles that I already know now. So if I know that angle A, which is this one here, is 120 degrees, I'm not drawing this perfectly, is 120 degrees. Let's make that a bit bigger. That's going to help me to find angle B, which is down here. And I'm using this rule a lot of times today. You see that it's not an F, it's not a Z, it's a C pattern. So I've got another C pattern with A and B, and it might help if I label on my diagram that A is 120. So that means I know that B is going to be added to 120 to make 180. Okay, so I'll do interior angles. And again, for your benefit there, I'm writing that that's a C pattern. But that just means that A plus B equals 180. And that means that A being 120 plus B equals 180. Again, with the equal signs like that. So B on its own is going to be 180 minus the 120. That makes B equal to 60. Okay, so I've got A, I've got B, and you know what? That's actually enough. I don't really need to do any other working to find C and D, because remember, this is an isosceles trapezium, which means I can draw a line of symmetry here. Let's do this in orange here. That's my line of symmetry, which doesn't just mean that these sides are equal to each other, but also these angles. So our last rule and our last bit of working here is all based on the symmetry of isosceles trapeziums. Okay, so no real algebraic working for this, but we do need to explain our working by just writing this out, that D will be equal to A and C will be equal to B. I already know what A is, so I just have to say that D is equal to 120 and C, because B is 60, is going to be equal to 60 as well, right? So if I just label in what I found there, so here we'll put B was 60, bold so you can really see it, and I know that C is also 60, and D is 120. The reason I just wanted to do that was to show you, remember at the beginning I was saying that I thought this was a parallelogram, but I wasn't entirely sure. Now we can check and see if this is a parallelogram, this angle here would be the same as this angle up here, and it is. This is 60 degrees, and this is an equilateral triangle. This is also 60 degrees. And the 120 degrees will be the same as this angle down here. And it is because, remember, this is an equilateral triangle. This is 60 degrees here, which means that 60 and 60 will make the 120. So it is a parallelogram as well. Okay, so hopefully that helps you to get a good start. Remember, the most important thing I need you to do today, though, is identify the rules and show the algebraic working. I don't want to just see answers on the page. The working here is what we're practicing. Okay, so good luck with that. Let me know if you need any help, and let's get going.